Hello everyone, I welcome you all to our course Engineering Mechanics. In this video, let us learn about what is force, what are the characteristics of force, and what are different force systems. As you all know, force is nothing but any action that tends to change the state of rest or motion of an object, or the force may change the shape of the body or size of the body when it is acted upon, or sometimes it will change the position of the body also. Let us see all the actions, all the effects what force can cause to the object here. It may get translated, it may get rotated, or there may be change in shape or size. Examples of forces, you know, so many: gravitational force, centrifugal force, or any applied force, or so many forces. Now let us see what are the characteristics of force. To tell what effect is going to take place on the object by the application of force, what all information do you require? Let us see that. First of all, we need magnitude of the force. How much force you are going to apply? You are applying on the body, and in what direction you are applying. For example, here we can say 30 degrees with horizontal. Then sense of force. Are you pulling it or are you pushing it? Sense of force is important. Another important thing you must know to predict the effect of the force on the body is point of application. Exactly where you are applying this force on the object. If you know all these four characteristics of the force, then easily you can predict the effect that is going to take place on the object. Here we are mentioning that force, we must tell magnitude and direction of the force. That is why we can say that force is a vector quantity. Now let us see the system of units of force. We know there are some basic systems of units called CGS, FPS, MKS, and SI system. In this course, let us use only SI system of units. In SI system means International System of Units. In International System of Units, let us see some basic quantities. What are the units of some basic quantities? Mass, you know, kg or kilogram is the unit. For length, meter. For time, seconds. And force we represent in newtons. What is 1 Newton force? 1 Newton force is nothing but force required to produce unit acceleration on unit mass. This definition we have obtained from Newton's second law of motion, which states that F equals to ma. Now let us see what are system of forces. When more than one force is acting on the body, we call all those forces as system of forces. All those forces together, they constitute a system of forces. There are different types of systems of forces are there. But what is the need to find those systems of forces? Because to predict the effect of these number of forces on the body, if we classify them into different systems, it will be easy for us to predict the effect of all these forces on the body. So let us learn what are the different systems of forces. First of all, the force systems, we can classify them as coplanar force system and non-coplanar force systems. Non-coplanar force systems can also be called as spatial force system. Here, you see in this example, all the four forces here shown are acting in the same plane. They may be acting in different directions, but all of them are acting in the same plane, that is the top surface of this object. Then we call this force system as coplanar force system. In non-coplanar force system, it is not necessary that all the forces must act in the same plane. They can act in different planes. Here if you see, the force A and B are on the same plane, that is on the top surface. And here the force C and D, they are acting in one vertical plane. And here this 4 Newton force E, is also acting in one vertical plane, but that is different from the plane in which C and D are acting. C and D are acting in a plane tangential to this object at the side. But this 4 Newton force is also acting in a plane tangential to the object, but which is parallel to this plane. And here the force F, it is in completely in another vertical plane. So this force system, it is called as non-coplanar force system. Here, in this example of seesaw, the weights of both the men are acting downwards vertically in a same vertical plane. And here, in this example of kite flying in the air, wind is acting in one direction and the tension in the string is in another plane, and the forces, lift force and drag force acting on the kite, they are in a perpendicular plane to the force tension in the string. So here all these forces are non-coplanar forces. Now another classification is concurrent force system and non-concurrent force system. Concurrent force system, all the forces acting on the body, they must meet at one point. Either the forces or the extension of the forces. That means the lines of action of the force, if they meet at one point, then we can call the force system as concurrent force system. Coming to non-concurrent force system, here if you observe, the forces C and D are meeting at one point. But forces A and B, they cannot pass through this point of concurrency of C and D. Therefore, and even the force E also cannot pass through the point of concurrency of C and D, same as with F. So here I can call this force system as non-concurrent force system. One peculiar observation is, in case of concurrent force system, there is only possibility of translation. There is no chances of rotation. But in case of non-concurrent force systems, there is chance of translation and rotation also. If you imagine this entire object as a single particle, then in case of concurrent force system, there are no chances of rotation, and a non-concurrent force system can create rotation also. Parallel force system is also an example of non-concurrent force system because they are not meeting at one point. Here, if this example, practical example, if you see, this man is trying to lift the rod from ground and he wants to make it stand. Here, tension in the string and the normal reaction exerted by the ground on the object, weight of the object, everything, three forces are there. If you join them, the lines of actions, all the three forces are meeting at one point. So this can be called as concurrent force system. Whereas here in the second example, the tension in the string is in one direction and the force applied is in another direction, and the normal reaction exerted at B is in another direction. So, and all these forces, tension in the string in the C, it will pass through C, applied force is passing through A, and normal reaction at B, it will be here. So all of them, they cannot meet at one point. That is why it is called as non-concurrent force system. Now the next classification is collinear and non-collinear force systems. In case of collinear force system, the forces are the lines of actions. They must be along a single line. The directions may be different. They may be opposite to each other, or all the directions of the forces may be in the same direction, but they will act along a same line of action. In case of non-collinear force system, all the forces need not act along the same line of action. They can be parallel also, they can be concurrent also, then we can call them as non-collinear forces. Famous game tug of war is an example of collinear force system, and here the forces of these two men acting on the seesaw is an example of non-collinear force system. Here, now the next classification. Within the parallel force system, we can classify them as like parallel force system and unlike parallel force system. Like parallel force system means all the forces must be in the same direction. Unlike means they will be in opposite directions. If we see this example, these bullocks pulling the cart, this is an example of like parallel force system because both of them pulling in the same direction. If you observe the steering wheel, here, when we rotate the steering wheel, one hand we put on one side and one hand we put on another side, and when we apply forces like this, then only we can rotate the steering wheel. So this is an example of unlike parallel force system. Now we have seen different force systems. Now, combination of all these force systems are also possible. Let us see what possible combinations are there. First one, coplanar collinear force system. When forces are collinear, they should be coplanar also, because if they are acting in one line, along one line, that line is a part of a plane. So, collinear force system should always be coplanar only. Non-coplanar collinear force system cannot exist at all. Coplanar parallel force system. Here, the forces are not collinear, they are parallel and they are in same plane. Then we can call it as coplanar parallel force system. Non-coplanar parallel force system is also possible. What you can see here, these two forces are in one plane and these two are in other planes. So this is non-coplanar parallel force system. That means this is possible in space in 3 dimension only. Now coplanar concurrent force system. Here these three forces are the concurrent ones and they are acting in the same plane. That is why coplanar concurrent force system. Non-coplanar concurrent force system is also possible. Here force S is in the horizontal plane and force P and Q are inclined in an inclined plane. Coplanar general force system is also possible. Here, in coplanar concurrent force system, forces must meet at one point. In case of coplanar general force system, forces will not meet at one point. Non-coplanar general force system is like this. These are the references for the pictures used in the video. So thank you very much for watching this video. In our next video, let us try to find out the resultant effect on the forces by calculating the resultant force of all the given forces.